The concept of counting and tracking things by numbers has probably been around ever since there's been more than one thing to look at. In the beginning, I'm sure it was all very simple. But as time passed and humans became more inquisitive, they found themselves stumbling upon questions they suddenly felt the need to have answers to. They came across curiosities and felt the need to know the truth. How many stars are in the sky? How many trees are in the forest? How many fish in the sea? As these questions and curiosities came to be, so did the need to have a written language for numbers and equations. With that, they could record their thoughts, put it aside for a while, then come back to it after thinking things over for a bit. It gave them the ability to pick up right where they left off. Thus, both recorded history and the age of scholars began. Each scholar, in every language all over the world, over time, made a gallant effort to come up with an adequate and dependable numerical language, and for the basics of it, they all did a pretty good job. The problem was that as time passed, people became even more curious, pondering questions that were deeper and wider. The numerical systems in many languages became difficult and cumbersome. The language of numbers couldn't evolve with the thinker's needs. Until the Arabic numerical system, a decimal-based system based on 10. The Arabic numeral system carries this name not because of where it's from or what language it's in, but because it's named after the guy who's credited with coming up with it, Aryabhata. Aryabhata was a mathematician and astronomer from India who was alive and practicing his trade during the 5th and 6th centuries. He's the guy who is credited with coming up with the 0 to 9 numerical system we here in the U.S., and as it turns out most of the world, uses today. Question for you. If the numerical system we use is called the Arabic system, what numerical system do they use in the Arabic language? The same one? Yes and no. They use the Arabic numerical system, which is in the Arabic language. What we know as the Arabic numerical system, they call the Indian numerals. Same thing, just different. Back to Aryabhata. His published works, neither of which I'm even going to attempt to pronounce, were reviewed, commented on, and practiced by mathematicians for hundreds of years. Of course, all of this is much more complicated than what I've explained here, and his writings include much, much more than simply 0 to 9. But for the sake of today's conversation, that's where we'll leave it. We're just talking about number systems, not all of the other theories he had and all the other topics included in his works. Eventually, the Arabic numeral system replaced the use of Roman numerals, which up until that point was the system in use in Europe. One of the biggest advantages the Arabic numerical system had over the Roman numerals was the representation of 0. There's a total of 7 Roman numerals. I equaling 1, V equaling 5, X representing 10, L 50, C 100, D 500, and M 1000. There's no 0. That lack of a number representing 0, a simple placeholder, and the need to subtract a lower number from the higher number placed directly on the lower number's right made it difficult and possibly inaccurate to use the Roman numeral system for in-depth mathematical equations. So the Arabic system, being easier to use and more accurate, took the place of Roman numerals. Ease and accuracy were two shining features of the Arabic numeral system. Another would be its lack of need to evolve with the thinkers as the equations became more and more complicated. The system, by design, could handle it. There are other languages that have no 0 representation as well. There's very few, if any at all, Native American tribes whose language has a word or symbol for zero, or Eskimo tribes. There's no zero in Saharan languages. I think if you added up how many languages don't have zeros, there'd be hundreds of them with no representation, either verbal or visual, for zero. The need for the Arabic numerical system to evolve did eventually come into play. New systems were designed to be used in place of the Arabic system where it was deemed a necessity. I feel confident to say you've heard of the binary system. The system is composed of two numbers, 0 and 1, kind of like an on and off switch, only two positions. You've probably heard of this in computing terms. Everything is zeros and ones. The binary system is also where the term bit comes from as it pertains to computer operations. In binary code, a 0 or 1 are binary digits, or bits. However, computers aren't the original intent of the binary system. It's been around for over 200 years. Computers aren't what it was designed for, but that's where it seems to work pretty well. There's also the octal numbers system. It's based on 0 to 7, and like the binary system, seems to work very well for computers, but wasn't designed for that use. Octal numbers have been around for the purpose of reducing the number of digits required to write out large binary numbers for about 200 years. The hexadecimal numerical system is based on 16 and uses the numbers 0 through 9 and the letters A through F. 0 through 9 represent themselves as they do in the Arabic system. Then the letter A will equal 10, the letter B equal 11, C would equal 12, and so on to F representing 16. It too was designed to offer similar aid with the number of digits required in the binary system to express mathematical value. Where did the system come from and how long has it been around? The term hexadecimal numbers seems to have first appeared in the early 1950s and seems to have always been computer related. However, if you look this up and read some of the articles on 16-based number systems, there's a lot to be found from a couple of hundred years ago, including people who were so excited about the 16-based number system, they wanted to change everything to it. Everything like 16 hours in a day and 16 months in a year. As far as I could tell, it never really did much until the 50s, but it seems that it was in fact another product of long ago. The existence of an operational and dependable numbers language is every bit as important as the words in everyday common conversation. Without numbers, or maybe I should say without a workable, dependable, and accurate numerical system, the world would be a very different place. Mathematics wouldn't exist. And as far as I know, everything, everywhere, depends on mathematics.